Welcome back, everyone. We are about midway through chapter 4 here, and we're going to talk about quadratic equations. Quadratic equations follow this pattern, and the key here is the x squared. There are numerous forms that we can write this as, and I'm going to give you a sneak peek down here. Doing some algebra to the general form here, we can end up with this form here. And we're going to focus on this where the vertex is at HK. I want to point out whatever sign is here, it's going to be the opposite here, and the K is going to be the same sign. And there's various reasons for that we don't need to get into. So for example, with part A here, the vertex is at opposite sign with 3, 2. So 1, 2, 3. 1, 2, here is the vertex. The vertex is on a parabola, either the minimum point, or if it's upside down, it's the maximum point. And again, we're dealing with this form here. So our vertex is at 3, 2, so we can kind of see our parabola, and we'll get more into graphing it here in a moment. Look something like that. For this one, the vertex is at, again, opposite sign, -1, -5. So that one's going to be here, -1, 1, 2, 3, 4, 5. So the vertex is down here. Something like this. So it's not too difficult to identify the vertex. Again, the tricky thing is if it's in this other form, we can do this. So the vertex, when we're in this form, is HK. When we're in this form, the vertex is here. The x coordinate is there. And to find the y coordinate, you would take whatever value you got for the -b/2a, and you would plug it into the original to get the second part. So again, the two main forms that we're going to be dealing with are here, and let's bring that same screen. I can, and here. So for our parabolas, these are going to be the two main ones, and I think we're going to focus more on this one for today. So part 2, we're going to complete the square. In other words, we're going to go from this form to this form using the same complete the square from here. So let's see what that looks like. All right, so part A, we are going to complete the square, and this is going to get a little tricky. So first off, I'm going to rewrite it f of x equals 4 times x squared minus 6x plus 35. Now here's where it gets a little tricky. I'm going to complete the square here. I'm going to take that 6, I cut it in half, 3, square it, 9. So I'm going to end up with this. So I added a 9. Now here's the trick. I didn't just add a 9 here. I added a 4 times 9. Added a 36. So to compensate, I'm going to subtract a 36. We've now completed the square. And we are now in our vertex form. Standard form. And we can clearly see the vertex. Remember, opposite sign, 3, -1. All right, let's try part B. I'm going to do something similar to here. So now I'm here. So I'm going to factor the 3 out. So again, this is going to get a little tricky. I'm going to take the 1, cut it in half, and square it. So I'm actually, to complete the square, this is f of x. So I'm actually, to complete the square, I'm going to add a 1/2. However, we need to know that I'm not adding 1/2, I'm adding a 3/2. Fourths, 3/4. square. So that's going to be minus 18 minus 3/4. And again, the 3 times the 1/4 gives me the positive 3/4. So to compensate, I have to do this. Now I'm going to get a common denominator here of 4. Combine things up and end up with and just real quick, the 75 comes from the 18 times 4, and another 3 gives the 75. So there is our vertex form, and our vertex is at -1/2, opposite sign, same sign. All right, let's try part C here. This one, I don't have to factor anything else. So this just becomes f of x equals x squared plus 6x minus 7. And very nicely, that one's even again. So I'll be able to cut that in half, which is a 3, square that, which is a 9. And that really is a 9 because that lead coefficient, there's a 1. Compensate, subtract 9. That's going to give me plus 3 squared minus, was it 16? So we have a vertex at opposite sign, -3, same sign, -16. Part D is here. G of x, so I'm going to factor the 2 out. Take the 10, cut it in half. That's 5. 5 squared is 25. And in reality, I have actually added a 50, 2 times 25. So that's going to be plus 35. To compensate for adding the 50, I'm going to subtract 50. Oh, this is g of x. G of x equals 2 times x minus 5 squared minus 15. So our vertex is at opposite sign, 5, -15. Not too bad. Let's build an equation of a line. Let's use a different color. So we're going to have a vertex at 2, 7 that passes through the point 8, -5. We'll start here. I'm going to use the vertex, that's the h and the k. I'm also going to plug in the point for x. I'm going to have the 8, and for the y, I'm going to have the -5. So -5 equals a, which is actually what I'm going to be hunting for here. 8 minus 2 squared plus -5 plus 7. So again, opposite sign here, same sign here is the 7. All right, so I'm going to move the 7 over and square this. So this is 36a equals -12. A is -1/3. So my final function is 1/3 x minus 2 squared plus 7. Moving on. So we're going to find an equation again with the y-intercepts here and the x-intercept at 0, -3. So we already know that x plus 1 and x minus 3 are part of this. And so now what I can do is plug in 0 for x here and here, and -3 for y. X is now 0, 0 plus 1, 0 minus 3. And that's going to give us divide both sides by -3, I get that a equals 1 in this case. So what's y? Y is just x plus 1, x minus 3, and we can FOIL that together. X squared is 2x minus 3. And we could even write it in the other form if we wanted to as well, but that's good enough. Number 5, find B and C so that this has a vertex here. Cool. All right. So we know that y equals -4. The a for both forms is the same. And x minus 6 squared minus 10. And we can FOIL this out. Minus 10. Distribute. Four times 36. I don't know what that is. 4 times 36. Minus 144. Minus 10. That leaves us with y equals -4x squared plus 48x minus 154. So B in this case, B, is 48. And C in this case is the -154. All right. So graph the function using the transformations. So we're going to start with x squared. Now, I'm noticing a is negative in this case. When a is negative, that means it's going to be facing downward. So our vertex is going to be at +3, 1, 2, 3, +1. And if I plug in x equals 4 into here, that becomes 1 squared, which is just 1, so -2 plus 1 is -1. So the point 4, -1, 4, -1, so it's down here. Now, because of something called symmetry, which we're going to get into in just a little bit here, these are going to be the same on both sides. And the -2 in front means that it's much narrower. It's shooting downward much, much faster as we're looking at that. And just in general, the axis of symmetry, sometimes called the line of symmetry, depending on the textbook, is basically when you have a parabola, it's the line that cuts it straight down the middle and goes through the vertex. And it makes it like a mirror, like it's exactly the same on one side as it is on the other. And we're going to talk a little bit more about that down here. The axis of symmetry of a parabola, f of x equals a, and then we have the standard form, is the vertex of the parabola that would cut it in half. The equation of the line is x equals h. And if we're in the other form, it's x equals -b over 2a. So if we're not in this particular form. It's called the axis of symmetry because the parabola is symmetric with respect to this line, kind of exactly what I did up here, where it cuts it exactly in half. So we're going to graph this line. And we're going to make sure that we find the intercepts. I'm going to transform this into the other form. And I'm going to add a 9 there, which means I have to, let me show you what I'm going to do. Now, to compensate, that's not a 9, that's a -9. So I'm actually going to add a 9. So the vertex and line of symmetry are at +3, +1. Also, the line of symmetry is at x = 3. That's a vertical line that's going to go through that. So let's see what this graph looks like. And as I mentioned before, because it's a negative coefficient here, it's going to be headed downward. So vertex is at 3, 1, 2, 3, 1. So we're up here. And that actually is going to cut through. If I plug in a 1 here, let's say a 4, again, that's over here. 4 minus 3 is 1, 1 squared is 1. That becomes -1 plus 1, that is 0. And because of symmetry, it's going to be the same here. So here is our graph. The line of symmetry, right there. That's the line x = 3 is the line of symmetry. Goes through the vertex. Determine the maximum or the minimum of this without graphing. Well, we haven't used that other formula, so let's use this one. I could complete the square and put it into that form, but I'm going to use this one to find the x-coordinate. And actually what I'm going to do after I find that is dump that into there. So b in this case is -12. So -12 over 2 times a. A in this case is -2. So I have 3 negatives, so that means overall it's going to be negative, and that's 12 divided by 4, which is 3. Now to find the maximum or the minimum, which it's going to be a maximum because this is headed downward, we can tell because that is a -2. So I'm going to find f of -3. So -2 times -3 squared minus 12 times -3 minus 24. What we got here? 18 plus 36 minus -6. So the answer in this case is -6. Minimum or maximum refers to the y value. Not so bad.